Have you ever wondered how AI actually thinks? I'm not talking about just recognizing a cat in a photo or finishing your sentence in a text message. I mean real thinking, reasoning, planning, understanding context, and making decisions like we do. Most AI today is really good at one thing: pattern recognition. It can spot trends, find faces, and crunch numbers faster than any human. But what happens when we ask it to think more like us? To understand not just what it sees, but why it matters. That's where hierarchical reasoning models come in. These multi-layered AI systems aren't just the next step in artificial intelligence. They're a leap toward machines that can reason across layers of logic, goals, and meaning. In this video, we're breaking down what hierarchical reasoning models are, how they work, and why they could be the foundation for the next generation of intelligent systems, from self-driving cars to artificial general intelligence. Let's dive in. When we talk about reasoning, we're talking about something deeper than data crunching or pattern spotting. Reasoning is the ability to connect dots, make inferences, weigh context, and reach conclusions, even in situations we've never seen before. Humans do this effortlessly. You see dark clouds in the sky and you reason, "It might rain, I should grab an umbrella." You hear a sarcastic tone in someone's voice and you reason, "They're not being literal, they're being ironic." You didn't memorize those situations. You reason through them using experience, logic, and context. But for AI, that's a massive challenge. Traditional AI good at patterns, bad at reasoning. Let's start with what traditional AI does really well: pattern recognition. Neural networks, like the ones powering image classifiers, voice assistants, and language models, excel at finding statistical patterns in massive amounts of data. Show an AI 1,000,000 pictures of dogs and it will learn to recognize dogs. Feed it thousands of voice samples and it will learn to transcribe speech. But ask it something like, "If John is taller than Sarah and Sarah is taller than Mike, who is the shortest?" Many models will struggle, or just guess. Why? Because that's not pattern matching, that's logical reasoning, the kind of step-by-step deduction humans are great at, but AI still finds tricky. To understand where hierarchical reasoning models come in, let's break down the two dominant types of reasoning in AI. Inductive reasoning, data-driven. This is the bread and butter of deep learning. It looks at patterns in data and generalizes. Most dogs have fur, so this furry animal is probably a dog. In the past, emails with these words were spam, so this one probably is too. It's fast, it's scalable, but it lacks explanation. It can't tell you why it made a decision. Deductive reasoning, rule-based. This is more like classical AI. Symbolic logic and if-then rules. It's great for solving puzzles, doing math, making structured plans. Example, if A, B, and B, C, then A, C. If the door is locked and I have the key, I can unlock it. The problem? It's brittle. If it encounters a case outside the rules it knows, it breaks. Think about how we reason. We don't just memorize data or follow rigid rules. We do both fluidly. We recognize faces, inductive. Interpret sarcasm, contextual. Solve problems, deductive. Adjust to new situations, abductive, inferential. To build truly intelligent machines, AI must learn to blend these styles, not just recognize patterns but reason about them, explain them, and act on them with purpose. This is the gap in modern AI. Current models are amazing at predicting what comes next, like ChatGPT finishing your sentence, but they still struggle with understanding cause and effect, multi-step logic, long-term planning, adapting reasoning across situations, and that's exactly why hierarchical reasoning models, HRMs, are so important. They don't just see and react. They process information at multiple levels, from perception to interpretation to strategic decision-making, just like we do. In the next section we'll break down how HRMs work, and how they're changing the game. So now that we understand what reasoning is, and why it's so hard for AI, let's talk about one of the most promising solutions: the hierarchical reasoning model, or HRM. At its core, HRM is an AI architecture that tries to reason more like a human being, by breaking down thinking into multiple layers, from sensing the world, to interpreting what's going on, to making decisions. You can think of it like a human brain simulation, in structure, not biology. Let's break it down. HRM has 3 key layers. Just like we don't process everything on a single level, HRM splits its intelligence into hierarchical layers, each with a different responsibility. Here's how it works. Layer 1. Perception, the what am I seeing layer. This is the low-level sensory processing. It's responsible for taking in raw input, like images, sounds, or sensor data, detecting objects, actions, or signals. Example, A self-driving car uses this layer to detect a stop sign. A voice assistant hears your words, set a timer. At this stage, it's just recognition. No context, no decisions yet. Layer 2, interpretation, the what does it mean layer. This middle layer adds context and meaning. It asks, what does this input imply? How does it relate to past knowledge? Are there any patterns, rules, or goals triggered? Example, a stop sign means I must slow down and halt. The phrase set a timer means the user wants a countdown to begin. This is where symbolic reasoning, rule-based logic, or probabilistic inference can be layered in. It's not just looking anymore, it's understanding. Layer 3, decision-making, the what should I do layer. Here's where goal-directed behavior happens. This layer weighs possible outcomes, chooses the best action, makes plans across time. Example, there's a stop sign, I interpret the rule, now I decide to brake before crossing. The user wants a timer, so I activate it, ask for the duration, and confirm the action. This layer is about intentionality and planning. It simulates thought over time, not just a reaction to stimuli. In traditional AI, these layers are often squished into one, or entirely absent. Too shallow, just recognizing stuff with no reasoning. Or too rigid, only following rules but clueless outside of them. HRM is different. It separates concerns. Each layer handles a specific type of reasoning, allows top-down and bottom-up feedback. Higher layers can influence lower ones, and vice versa, improves adaptability. The system can operate in both familiar and unfamiliar situations. A simple analogy, the way you cross a street. Let's say you're crossing a street, your eyes see a red light, that's layer 1, perception. Your brain recalls, red means stop, that's layer 2, interpretation. You decide to wait until it turns green. That's layer 3, decision-making. Now imagine a robot that can do all of that, safely, reliably, and without being explicitly programmed for every situation. That's what HRM is working toward. In the next section, we're going to take this idea further, breaking down each of these layers with real-world examples and how they're applied in cutting-edge AI systems today. Stay with me. It's about to get really interesting. Now that we've outlined the 3 layers of the hierarchical reasoning model, let's dive deeper into each one. To make it easier to follow, I'm going to walk you through a single, real-world scenario and show how each layer processes it, step by step. Let's say an autonomous vehicle is driving through a city and suddenly it encounters roadwork ahead with a detour sign. How does an HRM-powered system handle that? This is where sensors and deep learning models come into play. The system uses cameras, LiDAR, and radar to scan the environment. Neural networks detect cones, workers, detour signs, and flashing lights. It's recognizing raw objects, just like your eyes identify shapes and colors. But here's the key. At this stage, there's no understanding yet. The system just says, I see orange cones, I see a sign, I see a person wearing a vest. That's perception, raw recognition without meaning. Now the system starts reasoning. It pulls from stored knowledge. For example, what traffic signs mean contextual cues like cones plus flashing lights equals construction, maps, and previous experiences. The AI interprets the scene as, this is a construction zone, the road ahead is closed, the detour sign is directing me left. This layer transforms raw visuals into concepts and rules. Vest equals human worker, avoid. Arrow equals directional cue, update route. It's no longer just seeing the world, it's understanding what the world is telling it. Now comes action planning. The AI considers current speed and direction, nearby vehicles and pedestrians, destination goals, safety, and traffic laws. It decides to slow down, signal left, change lanes, and follow the detour safely. And it might also recalculate the route based on the new road layout. Here's the important part. It's not reacting blindly. It's choosing an action based on goals, reasoning, and predictions. That's high-level cognition. Strategic reasoning, not just reflex. If this was a traditional single-layer AI system, it might detect the cones, but not understand why they matter. Or it might recognize the sign, but not make the connection to change its route. Worst case, it just keeps driving into the blocked road. Flat models lack depth, but HRMs layer intelligence like we do. Let's try another, more human example. You say to your smart assistant, "Oh great, another Monday." Perception layer, hears your voice, transcribes your words. Interpretation layer, detects tone of voice, emotional cues, understands that "oh great" plus sigh plus context does not equal genuine excitement. Decision layer, decides not to send a calendar. Invite titled Monday Celebration. Might instead respond with humor, "Yeah, I feel that." This is how HRM enables empathy, humor, nuance, and intelligent interaction. By separating seeing, understanding, and acting, HRMs mirror how humans think. That means better safety in robotics and self-driving cars, more accurate predictions in medicine, more natural conversations in AI assistants, more strategic behavior in games and simulations. It's not just smarter AI, it's more human-compatible AI. In the next section, we'll explore why HRMs matter so much, not just technically but ethically and socially. Because once machines start reasoning like us, well, the implications go far beyond the lab, so now we know how hierarchical reasoning models work. But let's ask the bigger question, why do they matter? Why are researchers, developers, and tech companies so interested in HRMs? The answer is simple and powerful. Because HRMs bring us closer to creating AI that actually understands, not just predicts. Most AI today is impressive but narrow. It's trained on massive datasets, specific tasks, well-defined goals, and it works. As long as everything looks like the training data, but the moment you step outside of that bubble, the AI gets confused. It fails silently, or it makes mistakes that a human never would, because it doesn't truly understand what it's doing. It mimics intelligence, but it doesn't reason. Hierarchical reasoning models offer a major upgrade. They add structure, flexibility, and explainability to AI systems, and that opens up a whole new world of applications. Let's break down the key benefits. HRMs can apply what they learn in one context to many others. Example, a robot that understands danger in a kitchen can recognize a hot stove and a sharp knife, even if it's never seen those exact situations before. Flat models can't do that, HRMs can, because they reason across concepts, not just patterns. AI needs to adapt to the real world, and the real world is messy. HRMs allow AI to interpret ambiguous input, understand nuance, and react appropriately in unpredictable situations. Whether it's a medical diagnosis or a customer service bot, context matters, and HRMs can use it. HRMs can think ahead. Instead of just reacting, they can evaluate options, simulate consequences, and choose actions that align with goals. This is essential for fields like robotics, healthcare, defense, and autonomous vehicles, where wrong decisions can be dangerous or even fatal. One of the biggest challenges in AI today is the black box problem. We don't always know why AI made a certain decision. With HRMs, each reasoning layer is more modular and interpretable. That means developers can audit decisions, users can ask why and get an answer, and organizations can build trust in AI systems. This is crucial for industries like law, education, and medicine, where transparency isn't optional. Let's be clear, HRMs aren't perfect. They're powerful, but still evolving. Some current challenges: complexity. Building and training multi-layered systems takes serious time and resources. Data fusion, integrating perception, knowledge, and goals isn't always seamless. Bias and ethics. Reasoning doesn't guarantee fairness. HRMs can still reflect flawed data. So while HRMs bring us closer to true AI reasoning, they still require careful design, ethical grounding, and ongoing research. So where are we seeing HRMs, or HRM-inspired architectures, today? Some real-world applications: autonomous vehicles making split-second decisions, military drones analyzing battlefield dynamics, healthcare systems weighing treatment options, AI companions interpreting emotions in conversation. In every case, HRMs enable machines to go beyond reacting and start thinking in layers. In the next section, we'll compare HRMs to traditional AI head-to-head, so you can see exactly how much of a leap this really is. Let's go deeper. Now that you understand what HRMs are and why they matter, let's get really clear. How are hierarchical reasoning models different from traditional AI systems? Because on the surface, they might look similar. Both use machine learning, both process data, both make decisions. But underneath, they work in radically different ways. Let's break it down. Traditional AI: flat, fast, but fragile. Most traditional AI models, especially deep learning models, operate using a flat architecture. That means they take input like text or images. They process it through a deep neural network, and they output a result, all in one pass. There's no separation between perception, understanding, or planning. It's all tangled together in a single complex function. It's fast, it's powerful, but it's also opaque and inflexible. If something goes wrong, you don't know why you can't fix just one part, and it probably won't handle new situations well. Hierarchical reasoning models, on the other hand, are layered by design. They break the reasoning process into discrete stages. Perception: what am I seeing? Interpretation: what does it mean? Decision-making: what should I do? Each layer has a distinct role. and can use different kinds of AI, neural nets for low-level sensing, symbolic logic for interpretation, planning algorithms for high-level decisions. This separation allows for greater control, better transparency, more flexibility when adapting to new situations. Let's compare them directly. Architecture. Flat end-to-end versus layered multi-stage reasoning, pattern-based versus conceptual plus strategic context awareness, weak versus strong. Explainability, low versus high adaptability, limited versus flexible real-world use, good in narrow tasks versus better for complex open-world tasks. Transparency, black box versus modular and traceable example, email spam filter. Traditional AI looks at thousands of emails and says, emails with these words are usually spam. This one is too, it's a statistical guess. With no deeper understanding, HRM by contrast could break it down like this. Perception. This email contains urgent language, strange links, and financial requests. Interpretation. This pattern fits known phishing scams. Decision. Flag it, warn the user, and report the sender. Same task. Very different thinking. When things go wrong. Here's where the difference really matters. Imagine, a robot misidentifies a person as an object. A chatbot gives harmful advice without understanding tone. An autonomous car drives into an unusual construction zone. Traditional AI often fails silently. It doesn't know what it doesn't know. But an HRM can pause, ask for clarification, fall back on rules or context, or escalate the decision to a human. That's not just smarter, it's safer. In the next section, we're going to look ahead. Can HRMs lead us toward true artificial general intelligence, and what's standing in the way? Let's explore the future. Let's talk about the big question. Can hierarchical reasoning models help us reach AGI, artificial general intelligence? The kind of intelligence that doesn't just play chess or write emails but can understand, reason, and learn across any domain, just like a human. If that's the endgame for AI, then HRMs may be one of the most promising pathways to get us there. Why HRMs are key to AGI. To build AGI, we need systems that can perceive the world, interpret complex and ambiguous situations, set long-term goals, solve problems they've never seen before, learn from feedback, and adapt across environments. HRMs already do many of these things, just in a more modular and structured way than current flat AI models. Their ability to reason at multiple levels, from simple observations to abstract concepts, mirrors how humans operate cognitively. That's exactly the kind of flexibility AGI needs, from narrow AI to general AI. Let's put it this way. Narrow AI is like a superhuman in one specific task. AGI is like a curious child. It explores, questions, reasons, and learns across tasks. HRMs allow machines to build mental models of the world, switch strategies when conditions change, reflect on why something is happening, not just what. This ability to reason across domains is a core ingredient of general intelligence. What's still missing? But let's be honest, we're not there yet. Even with HRMs, we still face major challenges. Self-reflection. AGI needs to reason about itself. Why did I make that decision? What did I learn from it? HRMs don't yet have that metacognitive loop, but research is ongoing. Common sense reasoning. You and I know that you don't put a laptop in the oven. To an AI without world knowledge, that might not be obvious. HRMs still struggle with common sense knowledge and background context, the kind we pick up from everyday life. Open-ended learning. AGI must learn and evolve continuously, without retraining on massive datasets. HRMs today are often trained in bounded environments. We need systems that can adapt on the fly like human learners do. So, are HRMs the future? Not the only future, but a very likely part of it. In fact, many leading labs are already experimenting with HRM-inspired architectures. OpenAI and DeepMind are exploring multi-agent and hierarchical learning systems. Robotics labs are integrating HRMs for safe planning and decision-making. Neuroscience-inspired models are being layered with hierarchical control systems. The trend is clear. To reach AGI, we're moving towards structured, interpretable, and multi-level reasoning. Exactly what HRMs offer. So no, AGI isn't here yet. But hierarchical reasoning models, they're one of the clearest signs that we're headed in the right direction. Coming up next, we'll explore real-world projects and technologies already using HRM principles, and how they're changing everything from transportation to healthcare. Let's keep going. We've talked a lot about theory. Now let's bring it down to earth. Because hierarchical reasoning models aren't just abstract ideas in research papers, they're already showing up in the real world. From robotics to gaming to healthcare, HRM-inspired systems are powering some of the most advanced AI applications out there. Let's look at a few standouts. Waymo and Tesla, autonomous vehicles. Self-driving cars are a perfect example of where layered reasoning is essential. Perception layer detects lanes, signs, people, and other vehicles. Interpretation layer understands traffic laws, predicts pedestrian intent. Decision layer plans the route, stops for hazards, recalculates in real time. Companies like Waymo, Tesla, and Cruise use AI stacks that mimic hierarchical reasoning, because anything less would be unsafe on the road. DeepMind's AlphaStar and AlphaGo. In complex games like StarCraft 2 and Go, strategy unfolds over multiple levels. Tactics, long-term planning, reactive adjustments. DeepMind's AlphaStar didn't just react, it learned to reason, plan, and adapt across layers of strategy. Its architecture combines neural perception to observe the game, policy networks to make decisions, value functions to plan outcomes. This is practical hierarchical reasoning in a competitive environment, and it beat world champions. Boston Dynamics, advanced robotics. Boston Dynamics robots, like Spot and Atlas, navigate dynamic physical environments. To do this, they use layered systems that perceive surroundings in real time, interpret terrain and obstacles, make high-level decisions on movement, balance, and task completion. This isn't just cool acrobatics, it's real-time hierarchical control in action. IBM Watson Health. In the medical field, decisions aren't black and white. Watson uses HRM-like pipelines to interpret medical records, identify possible diagnoses, evaluate treatment options, recommend personalized care plans. Each step builds on the previous perception, interpretation, decision, which mirrors the HRM structure. While Watson hasn't fully replaced doctors, it shows how layered reasoning can support critical high-stakes decisions. OpenAI's multimodal systems. OpenAI has begun experimenting with multimodal reasoning, combining vision, language, and logic. Future versions of models like GPT, CLIP, and Codex may incorporate sensory input, contextual awareness, strategic planning. These models are inching toward HRM principles, layering understanding rather than treating everything as a flat prediction. What these projects have in common: they all combine perception, interpretation, and decision-making, use layered architectures to handle real-world complexity, reflect the core philosophy of the hierarchical reasoning model, and most importantly, they show us that HRM isn't science fiction anymore. It's real, it's working, and it's only getting smarter. Up next, we'll wrap everything up and ask the big question: what does this mean for the future of AI? And for us? Stay tuned for the conclusion, so let's bring it all together. We've explored what reasoning means in the world of AI, and why most current systems, while powerful, are still fundamentally limited. We've broken down the hierarchical reasoning model, a structure that mimics how we think, seeing, understanding, deciding. We've seen how HRMs allow machines to make sense of the world, adapt to change, and plan with purpose, not just react to patterns. And we've looked at real-world examples already using HRM-like systems to reshape industries, from autonomous vehicles to advanced robotics to medical diagnostics. So what's next? HRMs aren't just a better way to design AI, they're a step toward artificial general intelligence, the kind of intelligence that can think, learn, adapt, and reason across any domain. But here's the thing: building smarter AI isn't just a technical challenge, it's an ethical one, it's a human one. As we push closer to machines that think more like us, we have to ask, how do we design systems we can trust? Who gets to decide what good reasoning looks like? And how do we make sure AI works for humanity, not against it? Let's continue the conversation. If this video got you thinking, that's the point. So here's what you can do next. Like this video if you learned something new. Subscribe for more deep dives into the future of AI. Comment below. What's one thing you think AI should never be allowed to decide? Let's talk about it. Let's stay curious. And let's build a future where machines reason with intelligence and integrity, because the future of AI is us.